Good afternoon. Welcome to the webinar AutoCrear news in version 2.1. I'd like to make a short introduction about the product, about the company, about me, especially about the news in AutoCrear version 2.1. And here are, let's say, the general news about or in this new version. This will be presented by Michael Martinek. That's the founder, the CEO of e-laborate, and let's say after the first session he will talk about new capabilities in AutoCrear. There is a new ODB version, new interface where you can include where you can, let's say, analyze some PCB data. That might be a very interesting thing. At the end of the webinar, we have a short session, Q&A session, so please write your questions in the question panel of GoToWebinar, and so we'll try to answer your questions at the end or during the webinar. Let's start with the presenters. Right now you hear Urs Simler. I'm a CAD simulation specialist. I'm working for a reseller of e-laborate. This reseller is called GIA Informatik, and we are located in Switzerland. My colleague, my sales guy of GIA is Daniel Losley. Here are his, let's say, coordinates, and I'm very proud to announce Michael Martinek. He's the founder of the company e-laborate. He's the CEO, and let's say he's the brilliant brain behind that great product AutoCrear. So he will show you quite soon, present you the news of AutoCrear version 2.1. So right now here, many thanks to Michael that he took the time to join us. Some words about GIA Informatik. GIA Informatik is a reseller of PTC reseller. We are located in the middle of Switzerland. Beside, let's say, the CAD CAM products, we are an SAP reseller. We have IT services, and we'd like to, let's say, support our customers. We support our customers with the following products in, let's say, the CAD environment here. The main company we support is PTC, and we are also partner of e-laborate. In that environment, we're doing sales training with the PTC products. Beside that, we are supporting AutoCrear. We have some topology optimization and other products. Beside that, we are monitoring the PDM system of some Swiss customers, and we have an own training center in, let's say, our location, our main quarter in Oftringen.
Yeah, sorry, I hope you didn't have to wait too long. Somehow our landline broke down, so I just made a hotspot on my mobile phone, and I hope that the bandwidth is big enough so that you can see my presentation. I couldn't hear it, what you were saying, Urs, but I think you made a great introduction to this webinar.
I told the audience you are the brilliant brain behind that product we're going to see right now.
And also thank you very much for organizing this webinar. Yeah, Michael Martinek, I'm CEO of the company e-laborate Innovations. We are the developers, inventors of the software AutoCrear. And in this webinar, I would like to show you the new features in version 2.1. So it's not a basic introduction to AutoCrear, so it's more addressed to active users who are already familiar with the previous version, but of course all others are also very welcome here. The presentation will be split into two parts. In part one, I want to show you the features of the basic module, and in the next part I would like to show you a new module we introduced in AutoCrear, which allows you to directly import ECAD data. Since we are quite late now, let me just continue. I had to switch to another computer, so I hope I could bring all the data here. The first feature I'd like to introduce is the concept of net groups, which is an additional hierarchy level on electric nets. We distinguish between two different types of net groups, the uniform net groups and the non-uniform. The uniform net groups, in uniform net groups, all the nets in the group have the same electric potential. So you only have to define one clearance and creepage rule between groups and not between the individual nets. So this significantly helps you in the process of assigning the analysis parameters, whereas non-uniform net groups keep their individuality concerning the potentials, so you can define rules between the nets inside a group. The purpose of these non-uniform net groups has more lies more in the documentation. And for this I would like to give you an example. So let's switch to AutoCrear. Suppose you have some electric nets. Let's take these three nets here, main A, main B, and main C. These are three individual nets which have requirements between each other. We can see the distances also in the classical way here. But now imagine you want to know what is the global minimum distance between the entire group of these three nets and let's say this screw, for example, here. In order to get this, in the previous version, you would have to go through all the individual nets here, the main A, main B, main C, and then check the distance to the screw, and then add this information manually. So, and also the documentation you would have to do manually. And this we can do better now with net groups. So for this we go back to the electric net definition, and here I can select these three nets now and tell the program to group them together. Let's make a new net group here and call them mains. Here, as you already saw in this drop down, there are two net groups already here. These are global net groups. I will come to them later. Now we have a new group. I can also assign them, for example, to a group. These are the sides as they are on the two different sides of this assembly. And now you have a new kind of display here in this list. You can also switch back to the traditional display where you see the individual nets. However, they are at least colored in the color of the group. You can also edit your local net groups. Here we have two active net groups. You could change the color, change some more settings. And if I perform the analysis now with this kind of this is more cumbersome than on my usual screen because I only have one screen here on my laptop. So yes. No. Only allowed to open it once. So here we have a session with groups. So if we compute this in the setting we just made, we can switch here to a new kind of result display. So while you can, in this mode, you can still see the traditional individual nets, whereas here in the net group setting, I can select an entire group as a source, and now I have this screw as a target, and this is exactly the list I wanted to have here. And I have this now in one single view. This will also be in the documentation. Let's open an example here. So in the documentation, when I start the document tool, you now have a new option here, list net groups. If you activate this, the net groups will also be considered in the documentation, and will look like this. For example, here in this you have the mains to the tops cover screw. This is the example we actually wanted to have. In contrast to these non-uniform net groups, where all the individual nets inside the group stay or remain their individual voltage values, we can also define uniform net groups. If I do this by, let's edit the local net groups, make the mains uniform, then all the individual nets have the same voltage. I can type in the voltage here, let's say numlock 100 volts, and then you see here that all the individual nets get the same voltage value, and I cannot edit them anymore. And if I go on now to the analysis parameter, then you can see that you only have to choose the group, and you can define all the values to the other nets, or if I choose another net, you only have to define the distance to the group. You could have the same effect when you just merge together the nets to one net, but then you lose the information in the results tab, because when you do it with groups, you can still choose between the individual nets display. Then there is another thing about net groups. The net group I just defined in the way you saw are locally defined in the session. They are also stored in the session. If I reopen the session again, they are there still. But if I open a new session, you would have to define these groups anew, unless you define global net groups, which you can do in the tools, net groups, and here we have predefined two global net groups, and they are always available as option in the assignment of net groups, as you have seen here. Here are the global net groups and the local ones. If I assign a global net group, then they also appear, or you get a local copy of the global net group here in the local net groups, and I can do changes here, for example, change the color, change the voltage, without affecting the global net group. Okay, I think this is all I can say about net groups. Let's continue with the next feature, the altitude correction. Altitude correction is meant for assemblies which work above 2,000 meters sea level. So we have requirements in standard tables which are below this value, and if you go higher with your assembly, you need to multiply your distance values with a certain factor, and according to the height you see the factor here. This is one example of an industry standard, and you can now use such tables also in AutoCrear, and let me show you how. So let me first of all reload the session with the results. So the first thing you need to do, it's an initial step, you need to bring tables into the program. And you can do this here in the tools, altitude correction, and this works very similar as the standard tables. So these tables are stored in an external file. You can edit them in Excel. You can also edit them here in AutoCrear. You can also create new ones here in AutoCrear. And by this you can bring as many tables into the program as you like. For example, I have established 3 of these altitude correction tables here, and once you define them, you can use them in the analysis tab. So where you define your clearance and creepage requirements, and here in this section you can now choose one of your tables, and if you do this, click apply, then here you will receive the information that you use in altitude correction, and you also get the maximum multiplication factor. So when I perform a computation now, the standard values are taken, but the computation is going on not to this clearance value, but to this multiplied with the maximum factor plus the tolerance, of course. And in the results, then you can, let's switch to the traditional, you can switch through the altitudes. So this is, for example, the basic rule up to 2,000 meters, and now if I increase this, then you will see how here in the indicators that you get more and more violations. So 5,000 meters here are more violations, 8,000 meters we have almost all net pair is a violation here. So this is very convenient to work now with altitude corrections. Before that you would have to perform new analyses on different configurations, but now you can hold all your altitudes in one configuration. And also this has an effect on the documentation. Let me try to find some here for example. This is a clearance path which is okay actually for the basic rule, but you have here the additional information. Above 6,000 meters it is a minor violation, and above 7,000 meters it is a major violation. I would also like to point out that we recommend that you use only an altitude correction table up to the value you require. Otherwise you would waste a lot of time. For example, if we would always apply this table here, which goes up to 20,000 meters, the maximum factor for 20,000 meters is 14.5, and computing 14.5 times the clearance rule will probably take 200 times more than basic rule. So make tables as up to the height you require, not in order not to waste your time with unnecessary computations. The next feature I want to introduce is the feature that you can import and export matrices for the user parameters. I have an example here. You might have such tables where you just defined distances directly between the net pairs, or also your net group names and net group pairs. One for clearance, one for creepage, one for growth width. And if you have such tables, you can now directly import them into AutoCrear. Let's make a new configuration. So now we have a naked configuration. There are no distance values here, and now I can go to this option here, import configuration from spreadsheet. Now I can choose this matrix, and you see the values are now automatically filled with the values from the matrix. You can also export such a matrix from the program with the export configuration to spreadsheet. Then you can create such tables from your current parameter configuration. So then the next thing is the test finger and the surface cover, which we introduced as additional features for the samples. Samples are part of the electric net definition. you can create samples. In the previous version, you know, you can distribute points on your assembly or surfaces, and now we extended these features by these two additional elements. And let me show them here live. So if I would add a new sample here you see the options. These are the old ones, and now a surface cover is a way to cover holes in your assembly. For example, if you want just to cover this hole because you might need to fulfill distances from the interior to a virtual metal foil covered here, then you can just click on this surface here and the holes will be covered automatically. The other new feature is the test finger, and we introduced the EN61032. This expects you to define a reference point where the finger will initially be placed, for example this one, and it will be automatically orientated on the surface normal of the point you clicked. You can now additionally move this point along its normal. Well, of course, there is more to come in order to more handles where you can move this finger freely around. This is the first version where you have a very simple way of placing this point, this finger by a reference point and an offset. And if you need other test fingers than the EN61032, then tell us and we can introduce more of these fingers here. And if you apply this, you have the finger as a regular electric net, and you can compute clearance and creepage paths to this finger. So then we introduced a new type of voltage. This was motivated by the fact that we now can work on ECAD data as well. And in this ECAD data we have seen that the clearance is often, or the clearance and creepage often refer to different types of voltages. So the regular voltage is referring to the creepage values, and the clearance rules are often defined on the voltage difference according to some peak voltage, which occurs only for a very short amount of time. For example, if this net has 220 volts actually in the working voltage, but in peak it can have 500, then you can type it in here, and for the standard tables the maximum voltage difference between two nets for the clearance will be taken from the rated voltages, whereas for the creepage it will be taken still from the regular voltages. Then we have extended the model tree on the left side of the program by the possibility to add more columns to it. This was an idea of many customers. As you know already, you can import certain additional attributes from your parts. For example, here I have typed in that I want to import the attributes model by ID and description for each part, or in this case also for an assembly. And to show them, you can now add additional columns here, and for each column you can now choose what to display on this column. For example, here the ID, let's add another column. just right-click on the header, and then you can activate additional parameters here to see them in the model tree. What you can also do is you can change these attribute or the values of these attributes locally. So you have a local copy now of your attributes. You can change it for your AutoCrear session if you like. Or you can also introduce entire new attributes which only live in your AutoCrear session, which is maybe suitable for documentation. If you need some attributes for your components documented in your analysis report, then you can type here arbitrary strings, and they will be documented then in the report without changing your original geometry, original CAD data. So then we revised this tool where you can measure simple distances, which is a general tool which you find here. In the previous version, you could just select two arbitrary points. You get the Euclidean distance, and now you can choose more geometric elements. For example, a point, and it also makes an automatic snapping to the closest corner or closest edge. For example, I want to have this distance, Euclidean distance between this point and, let's say, this surface here, and then you get the Euclidean distance here. This also works on other types of elements. Or you can also measure the distance of an arbitrary polyline. If I choose this option here, now I can draw a line here, and you get the distance of this line here in this section. This can be useful if you maybe miss some paths which was not computed for some reason, and you want to measure a manual path here on this in certain areas. Then you can do it with this tool here. But actually, it's not necessary because you get a good path from the computations. So then this feature we introduced because, well, it's a lot of CAD tools have this. If you want to select, or if you select some, here in this case we select a component, then you always get the first hit below your mouse pointer. If you want to select things which are further inside of the assembly, you can hold the Alt key, select again, and then you get an entire list of all elements which are below the mouse pointer. So it's a kind of array we shoot into the assembly, and you get the list of all components we hit with this array, and you can select them here. This was inspired, as I said, from many CAD tools who have this feature. It was also a requirement of some users. Then we have some minor novelties. For example, you can activate the list of components in the documentation of the paths. So this is in the documentation panel, section clearance and creepage path group. And this group here, you can activate list involved components, and then they will be shown in the document for each component. Then we have introduced some new options. For example, you can now choose a working directory where temporary files are stored, and also where the ECAD components are stored, the database for components. Therefore, we introduced this feature, and I will come back to this later. Well, there's a new color you can specify for the distance measure tool, but this is not so worth mentioning here. Then you might have missed the hide insulators checkbox, which was previously located in the electric net tab. In this position here, we now moved this element to the global section below the model tree. Some users complained about the fact that they can only activate this tool inside the electric net tab, but they would also like to hide the insulators, for example, in the analysis parameter definition. So we just move it to here so you can activate this feature everywhere. The feature itself just hides everything, every part which is fully insulating, which is very convenient for the electric net definition. Then there is a new feature in the help section of the menu where you can send us feedback. If you have some ideas to improve the program, ideas for new features, you can now directly address them here in the program. Yeah, this was all about the novelties in the basic module.
One short moment. So far, thank you. There are no questions. We are good in time. So again, for the attendees, if you have any questions, please use the question panel. Thank you. That's all.
So the ODB++ interface is a new module we introduced so you can directly import your ECAD data into AutoCrear. If you wanted to analyze your electronic data together with your mechanical data in AutoCrear, you would have to do this in this way. First you have your ECAD data, which is two-dimensional. You would somehow get a 3D component out of it, which you can mostly do with step export, so every ECAD system can make a step export. Then you get a 3D version of your PCB, but well, the geometry is often not very clean. There are a lot of overlaps, a lot of unnecessary solid bodies in there. So when you import or export a step from a large PCB, then you will get thousands and thousands of components, and it's very hard to work with it because in the following you can import this step, of course, in AutoCrear, but then all the meta information has to be assigned anew. So what is insulating, what is conductive, and then the next step you would have to define your electric nets, and this can be very cumbersome in ECAD because there are thousands of nets on your PCB, and then eventually you can analyze. But the crucial thing is actually you have defined everything already in the ECAD data, especially the electric networks. So we find that this was very too cumbersome, and so we introduced this workflow now. So we developed an interface which can import ODB++ data. ODB++ is an exchange format for ECAD data. Every common ECAD system should be able to export the data as ODB++. It's lossless. Oh, I'm working on my, let's do it like this so it's bigger. It's lossless, so there are all the electric net information still there in the ODB++. When you import this in AutoCrear, then you get a clean 3D geometry. We generate a 3D object out of this data. And also the materials are already set, and the electric nets will also be automatically imported. So actually you can immediately start an analysis on this. Well, of course you might want to combine this with your mechanical. What was the last thing you could hear from me? Was? Hello? Can you hear me?
Yes. You explained the slide and then the audio was gone, so you can start with the live.
Yeah, there is, sorry, there is a button to mute my mic here, and this is very sensible, so I accidentally hit this button. So yeah, let's let's go through this through an example for the PCB import. So you see here in this bracket that it's still the beta version, and ODB files are either defined in a compressed file or in a directory. I might have a directory here. Yes, so this is the basic structure of ODB++ here. I can select this folder, import it, and then the first thing you get is an import mask. And I think everyone who's familiar with ECAD data will be very comfortable here with this. You can see all your layers, the components, the solder paths, the signals, the routes, drills, and so on. By default, all the signals and power grounds are activated, and the components and the drills. But as you can see, you can also import other stuff. Then you can choose some more parameters here, like colors, for example. But more important is this section here, the components. The problem with components is they are 3D data which are not in the ECAD data. ECAD data is purely two-dimensional. Maybe I can zoom a bit more to this section here. Here you see in yellow, zooming to the center, you can see in yellow the components. So there are outlines in the ECAD data and also heights, but there is no 3D data inside the ECAD data. So, but eventually you might want to replace these components by the original data. So we introduced a way to do this also. But we also have the possibility that you import them in a simplified representation. And this means that we generate boxes of these components according to the outlines and the heights we know from the ODB data. If I switch to the material colors, you will see that there's nothing red, so everything is already assigned a value. Also the geometry of this import, and you see that it was very fast, we could import it in just 4 seconds. The geometry is very compact and clean, so every layer is one solid body. The signals are embedded as surfaces into this body, and you also have we just imported all layers, not only the top and bottom layers, but all of them. Now what if you want to import your three-dimensional components as well? Well, here we have in the tools an option where you can administer your ECAD components. Now let me change the working directory here for, oh no, this, yeah, I prepared the webinar on my other computer which has no internet, so I need to improvise here. So I change the working directory to my webinar folder. Okay, so yes, this looks better. In this tool, you can administer your 3D database of components, and they are actually organized in the working directory in 2 folders. I can open the working directory here, and the 2 folders are, first of all, the ECAD source folder. Here you just place your original geometry files, step files or native files. Here, for example, we have a Creo file. And then we need an initial pre-process of this native data or geometry data into a proprietary format we introduced especially for this purpose, which is an ACE file, AutoCrear ECAD component. So every source file needs to have one ACE file. This is a pre-processed file for a quick import of the data. And you can also transfer the data from your source folder to the pre-processed ACE folder here in this batch process. And this green mark here on each original file tells you that there is an active ACE file in the database which is up to date. Now if I, for example, delete these two ACE files manually, so now I reload this, you will see here there is no green dot, so that means we need a pre-process of this data. And we can do this, and I recommend semi-automatic processing where every part is open and you can check some parameters. You can set some default things, for example, what is your default up axis, the default CTI value you want to assign. You can also choose to import attributes for the matching with the references on the ECAD data. And if I start this batch process, now we have activated two assemblies. Then you see here the process. We are in process 1 of 2 assemblies. Now you can check your assembly, and this, for example, it has a wrong axis. It's actually the y-axis. Oh no, it was actually good. The z-axis was correct. Yeah, because of this plane here, it shows you the plane where it's placed on the PCB. So you could correct the axis if not correct. You could correct the offset, and what you also can do is you can define the surface parameters here. For example, this is conductive. So, and if everything is fine, I click Save, and now an ACE file is written into the ECAD component database. And here I immediately see, oh, this axis is not the Z-axis in this case; it's the Y-axis. But in generally, if we have one database, it should be consistent. And also here, I see that the offset is wrong. I can offset this plane by selecting a reference offset here. I want that it's laying here in this plane on the ECAD. And then again the material assignment. So, and now this part is also done. Save. The batch process is finished. So this is a one-time thing you have to do on your database, and if you have established such a database, then you can use it in the import. So let's import this PCB again and choose the detailed representation. And now it lists all your components we found in the ODB data, which can be referenced either by part name or by package name. And either of them can be matched with the component name. It can be the name of the component in your data. It can be also attributes which you could specify in the import. In this case, it's obviously the package name we found in the ECAD component. For the matching, there are different settings you can choose to ignore suffixes and so on. So there are a lot of matching options which are described in the manual. But in general, this should work automatically. If not, you always have the possibility to manually choose. So if you start writing, you get a list of everything which is in your database. But actually, it should work automatically. In this case, everything was matched here. And if I import this now, then it will take 3D data and place them automatically on the correct position. And also you can see that all the materials are already set and we are ready to go on. Well, let us first combine this with mechanical data. Yeah, I have a frame here, for example. That was wrong. I should have to do add assembly, not import assembly. But now I can do it the other way around and just add the ODB file. And luckily this goes very fast, this import. So also for very large PCBs, it's a matter of seconds, or in very huge assemblies, maybe a few minutes, where you get this nice 3D version of the PCB. And now we would have to design the materials for the mechanical parts. Yeah. And we have a nice 3D model of our mechanics and the PCB generated in no time. If I apply this now and move on to the electric net tab, you will now notice, or notice in a few seconds, that there is already a lot of electric networks in your list of potential nets. And these come directly from the ECAD data. So here, these nets are the original nets, and we don't need voltages here, the original nets from your ECAD data. Let's switch back to material so we can see them better. So you can also choose a net here. See, okay, this is the net B7 from your data. Now you see that there is a lot of electric networks, and the thing with the ECAD data we learned is that you have thousands of nets on your PCB defined, but there is only a group of net groups, or a limited amount of net groups on which the clearance and creepage rules are defined. So actually you want to further work on the net groups rather than on these thousands of nets, because otherwise you would have to define your clearance and creepage rules here for this matrix, and this is cumbersome. So let's go back. And in most cases, this information is also in your ECAD system. We learned recently that you can also export them in ODB++, but most of our users have them in an extra file. In Zucken, for example, it's an RUF file. In Mentor, it's a CSV file. This is the two we yet support, but if you have other systems, just provide us the files and we can write parsers for them. So these files contain net group information. In the RUF file, I should have something here. And then switch to the net group. Then you see that we have everything now combined to 4 net groups, and if I now go on, then I would only have to define the distances between the net groups, and all the individual nets will get these clearance and creepage rules. And also these rules might be defined in your ECAD system, and just as with the net groups, you can export them in a file. In Zucken it's an MTX file, and you can import them here in this section in AutoCrear. So I import the MTX file from Zucken, and then I can also choose which rules I want to apply for clearance and creepage we find in the Zucken file. And then here everything is already assigned, and I can start an analysis here directly on this. I think I have prepared some results here on this, exactly on this data set. Yes, this is an example now of a result. So I have the mechanic here, these 4 mechanical parts, and now I want to know the shortest distance to this, to the ground. And now here it is. And it's even not one of the top layers, it goes into one of the inner layers. So let's show involved only is a nice feature here. Yes, and so on. So very convenient workflow now to work to bring together your mechanic and your electronical data to perform a combined analysis with the minimum amount of manual definitions here. And as I said, this feature is in beta mode now. It's freely available for every user, at least until end of this year. So feel free to test it with your data and also provide us with feedback. We are not the experts in ECAD, you are, but we are the guys who can make everything happen if you have further requirements concerning this workflow. So then this is the end of this demonstration, and now you can ask your questions in this question panel.
Yes, I'm looking at the question panel. Thank you so far, Michael. was very, very interesting, and for the attendees this was really a live demonstration. And you heard about that Michael lost his landline and he had to switch to his computer. So thanks a lot
Yeah,
for
my
the
mobile
interesting
phone,
demonstration.
my
I know
mobile phone
how
provider.
difficult it is to switch so in a short time to another system. So there are questions. Is there possible to define cover areas? And about this, you have bigger distance creepage. So I think you showed it that with these surfaces, the top surfaces. So I think the question is about, is it possible to define cover areas?
Okay, I think you mean that you can define certain, or you can, what we have here when we define analysis parameters, this applies for the entire assembly. And I think you want to apply different configurations on different areas on your assembly. This is definitely something we will address in the future. There are a lot of, especially in the ECAD area, there are a lot of requirements for this. It will be in the future. It will be now. Now a configuration is referring to the entire list. You can work with domains. You can make domains where you can change the geometric extents. But each domain has can only be, yeah, you can now make a configuration for this domain, but in order to compute the other side with a different setting, you would have to make a new domain. So one combined possibility to define regions, to define different configurations on the regions, and to perform one analysis on the entire assembly with a different region. This is not there yet, but it will be in the future. It's not easy because, for especially the user input will be hard to establish. Well, defining boxes is simple, but you might have more complex regions which you have to define in 3D somehow. We will make our thoughts about this, and in one of the future versions this will be available. Well, I hope this
Thanks.
was the feature you were asking for. So as far as I understood it, it was
and if you have any further questions, then don't hesitate contacting us, send us an email, or contact us by phone if you have further questions. There is another questions. Are PCB tolerances accounted in AutoCrear, or capabilities to account this?
Tolerances is a very interesting topic. Well, tolerances, you can add a tolerance here in the analysis parameters. So even if you have your, let's go back to the other domain, you have here your clearance and creepage distances according to the MTX import, or to this requirements you have. But you can also add a tolerance here, either absolute or relative. For example, add 10% tolerance, and then not only these 15 millimeters will be considered as critical, but also plus 10 millimeters. So this is the way you can address tolerances now. In the future, we also plan to introduce real geometry-based tolerances, so that you can select certain elements, tell the program in the beginning that this element can be moved by 1-2 millimeters in a certain direction, and then we will address this tolerance also geometrically. But this is very hard, and yeah, but this is also future work. Still, AutoCrear is our only solution, and we are developing on no other solution than this, and we will work on this day for day in order to bring all the requirements into one program concerning clearance and creepage.
Great, thank you. So if I'm looking at my watch, it's past, so I think we will finish here. So can you please go to the next slide,
Okay.
Michael?
Yeah.
Okay, thanks. So that brings us to the end of the webinar. Michael and I would like to thank you for your time. I hope it was worthwhile to see that AutoCrear has interesting news, and especially in the OBD Plus environment, existing customer can use this feature. And if you have any further questions, do not hesitate contacting us. So I would thank a lot to Michael Martinek for his time, for his excellent presentation, and I will give him the last word. Michael, do you have to
Yeah,
say
I
something?
hope that my bandwidth was good enough. So
This was
if you
very
would,
good.
okay, that's good. Yeah, it was kind of improvised now, but I hope it was going well. And I can imagine that we will make such webinars each time we have a bunch of new features in AutoCrear to present them to you in this way. So thank you from my side as well. Thank you, Urs, for the organization,
Thank you.
and
It was a pleasure for me.
hope to see you all soon,
Yes.
or to hear
Thanks a
from you
lot.
for your feedback whenever you have problems or wishes, requirements. Contact us anytime. We will work on that.
Thanks a lot, and we're closing
Okay.
the webinar. Enjoy the summer, and see you soon. Bye.
Bye.